Lesson 3.1, linear inequalities in two variables. Mainly going to be graphing today, but then there's also some application problems that we need to look at. And then there's definitely a decent amount of SAT problems in the practice, so we can kind of see how they word these type of problems and their spin on it. All right, so first section, graphing linear inequalities. I'll kind of hit some highlights as we go. And when I'm doing these, I pretty much treat it exactly like an equal sign in the beginning. So you remember, this is the y-intercept. Everything is still in reference to y equals mx plus b when it's in slope-intercept form. So my y-intercept is a positive 1, so that's where we cross. My slope is positive, so I know I'm going to be going up and to the right. The top number tells me to go up 1, and then I'm going to go right 2. So up 1 over 2, up 1 over 2, up 1 over 2. So I just kind of keep playing that game. And I go the other direction. Boom, 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 boom. Now, here's where it changes. Normally I would just, strike a line and I'd be done with it. So here's where there's a couple things we have to look at. First thing is, depending on whether or not it's less than or equal to, because it's just less than, we're going to have a dotted line or a dashed line. So whenever it's less than or if it's greater than, it's going to be a dotted line. It's going to be dashed. If it's less than or equal or greater than or equal, then it's going to be a solid or continuous line. So the first thing I want to do is I'm going to dash this line out. So, kind of cool, got my little dash thing going on. Now, the next thing is, I'm going to teach you two different ways to do this. There's a long way and there's a short way. And of course, on the SAT, I'm a big fan of the short way. But I do want to teach you the proper way to do it first. So what that line is, that line right here, this is a boundary line. All right. So we've just drawn the boundary line. And what that boundary line means, it means that one side of the line are solutions, the other side of the line are not solutions. And what I mean is when you have XY pairs and you plug them into that inequality up above, one side of the line will be true, the other side will be false. And if you live on the boundary line, you're not a solution because this is a dotted line. So meaning that those points are like right on the boundary, but they're not part of the solution set. Now, how do you know which side to shade? So that's my big question now. Which way do I shade? Well, the traditional way is to, when you shade, you choose, if I could spell the word choose, it'd be a little bit helpful. You choose a test point. So you choose a test point to plug in. Now, the best test point to pick is 0, 0 if you can. So I'm going to choose my test point 0, 0. One other thing, it cannot be on the boundary. You don't want to pick something on the boundary line because we already know right now it's not going to work because this is a dotted line. So pick a point not on the boundary line. If 0, 0 is available, choose it. So I'm going to test, what we're going to do right now is we're going to test 0, 0. Meaning I'm going to test x equals 0, y equals 0. And I'm going to plug it in up here. So 0 less than 1/2 times 0 plus 1. Well, when I work it out, that 0 is less than 1. And that's a true statement. So this is true. So since it's a true statement and 0, 0 is a solution, I now shade everything. I shade everything over here on this side. And that would be shaded. And then the top part is not shaded. And if I wanted to, you don't have to do this, but if I wanted to try a test point, let's just try a point like, I don't know, let's try this point. Let's test 1, 3. X is 1, y is 3. Let's go back and test it. It should be false. It should not work. Let's try it. So we have 3 less than 1/2 times 1 plus 1. That's 3 less than 1 plus 1 is 2. And that's false. 3 is not less than 2. So that means I should not shade the side that the 1, 3 is on. None of those ordered pairs on that side are going to work. All right. Now that's the long way, testing points. I'm going to show you on the next example how to do it a little bit faster and not have to test points. All right, so example 2. I go through here, I go a little faster. Boom, we got our y-intercept. We have our slope, which is 3 over 1. So we're going to go up 3, right 1, up 3, right 1, 3, right 1, 3, right 1, 3, right 1. Choom, choom. Now, because this is greater than or equal to, I want solid. So I'm going to do a solid line. All right. Now, on a solid line, the points on the boundary are solutions. They actually work because this is a solid line. So every dot on there makes that true because it is equal to. Now, here's the shortcut on the shading. I could test 0, 0. It'd be super fast and super easy to plug 0, 0 in, see if it works. But an easier way to do this is, if its y is greater than, all right, so if you see y is greater than, you're going to shade above the line. All right. Now it's a little, this line's pretty steep. If you think about above and below, just kind of go perpendicular to it. So perpendicular, this would be above. So all this side I know is going to work because it was y is greater than. All right. By contrast, if you had y as less than, or less than and equal to, either way, then you're going to shade below the line, which would go the other way. It would go down. So I already know this one's above, and we could test it. We could pick our spot 0, 0, and we could plug it in. 0 greater than or equal to 3 times 0, 0. Is 0 greater than or equal to -2? Well, yeah, 0 is bigger than -2. So you shade the 0, 0 side. But shading above and below is quite a bit easier. It's faster. All right, next one. Well, you have two options. One option is you could rewrite in slope-intercept form. So if you wanted to, you could change it to slope-intercept form. You could use intercepts. So you could do the x and the y intercepts, which I'm going to do that on this case because I see that both of these numbers go into 6. So I'm going to make a nice quick little table. Let's find the y-intercept by letting x equal 0. So if I let x equal 0, and I kind of cover that up, well, that's 2. 3 times 2 equals 6. And then if I want to find the x-intercept, I let y equal 0. And I get x equals 3. So there's my two intercepts. 0, 2 is the y-intercept. And 3, 0 is the x-intercept. And now I see that it's got a slope of down 2, right 3, down 2, right 3, down 2, right 3. Back it on up the other way, 2 and 3, 2 and 3. And now I have to ask myself a question. Is it solid or dashed? So this one is solid. And then we could either do a test point. I really can't use my greater than, my above and below just yet because I don't really have it solved for y. So maybe it'd be easier just to do a test point. Again, 0, 0 is not on the line, so let's try it. 0 plus 0 is greater than 6. Well, that's false. 0 plus 0 is less than 6. So don't shade that side. Shade the other side. All right, what else do we have here? Profit application. The theater club charges $7.50 for adult tickets, $5 for student tickets. The theater needs to make at least That's a keyword there. At least. So if I need to make at least something, that means I got to be greater than or equal to 240 to cover the cost of the show. So they have to spend $240 to put on the show. So they need to sell tickets just to get to break even. Then they'll start making some money. How many of each type of ticket must be sold? And if 20 student tickets are sold, how many adults must be sold? All right, well, let's do this. I'm going to scroll down so I can access my whole chart. $7.50 adult, $5 student. So $7.50 adult. Actually, let me just shrink this a tad. Might be easier than trying to fit it all in. There we go. That's not too bad. So why don't we do this? We're going to use X and Y. Let's do the adult tickets. Let's call this our X. And let's call the $5 student tickets our Y. And I can kind of set up an equation here because I'm going to get $7.50 times the number of adult tickets plus $5 multiplied by every single student ticket, the Y tickets, and I need to be greater than or equal to $240. So we could do a couple different things. We could try to use intercepts if we want to. Let's just see if that comes out kind of clean. So I'm going to try intercepts, see if that works. So if I let X equal 0, well, $5 goes into 240. It looks like that'd be 48. So how I interpret that is, if I sold 0 adult tickets, I would have to sell all 48 student tickets to get to 240. So I'm kind of looking at the extremes. I'm looking at if I sell none of one and all of the other. Well, then if we go the other way, if I sell 0 student tickets and only adults come, well, that would be 750x is 240. So 750x is greater than or equal to 240 if I let y equal 0. So I need to divide that out. Let me just use my calculator here real quick. And it might not be a nice friendly number, but we'll see. 240 divided by 7.5. Oh, it is 32. And it makes sense I would sell less of those tickets because they cost more. So let's try to put this on the chart. Let's kind of draw. We only need to draw the first quadrant because there's no negative tickets being sold. And on the x-axis, this is the adult. And on the y-axis, those were student. And so I need to kind of graph this equation. So 0, 48. Well, 48, let's call it 50. Maybe I'll go by 5s. So 0, 5, 10, 15, 20, 25, 30, 45, 40, 45, 50. And I don't really have to go much higher. And then going the other way, I got to get to 32. So going by 5s might not be enough. So I don't know. Get to 32. Maybe I'll go by 4s. I could do every 2 of them is 5. I don't know. Doesn't really matter. Let's just go 4, 8, 12, 16, 20, 24, 28. That'd be 32, and this would be 36. All right, so we're going up by 4s every single time. Now I got to put my 2 dots on there so I can graph this thing. Well, 0, 48 is right here. And down at the bottom, I have 32, 0, which is right there. And since it can be equal to 240, I can just come with a solid line. So there's the line that represents the combinations of tickets I need to have. So it says how many of each type of ticket must be sold to make a profit. So we kind of had those on there. We had either 48 students or 32 adults. If 20 student tickets are sold, so on the student chart, I got to go to 20. If 20 student tickets are sold, then how many adults must be sold? Well, I can cut across, boom, right there. If my graph is accurate, it looks like 20 adults. 20 student, 20 adult. And I could check that if I wanted to. If I do 20 students times $5 a piece plus 20 adult times $7.50, well, let's just see. This would be $100. And that would be, well, 2 750s is 15. That'd be 150. So it'd be close, but it wouldn't really be exact. Like that would definitely put me above 240. It would put me at 250. But I think I could even do a little bit less. I think I could actually do like 19 tickets and still meet my quota. So sometimes a graph isn't quite as accurate. So let me just go through and let me just maybe solve this one using algebra too, just so we can kind of see. All right, so let's take a look at the algebra kind of way that I could do this. So I go back to my equation. I have $7.50 times x plus $5 times y, which was the student tickets. And I need to be greater than or equal to 240. And it says, so if 20 student tickets are sold, so 20 student tickets are the y values. So I'm going to go 750x plus $5 times, and they're saying, well, what if you have 20 of these student tickets sold? I should be able to figure out the x tickets, or the adults. So that'd be 7.50x plus $100. It's greater than or equal to, doing the math a little bit fast in my head, 240 minus the 100 from both sides, 750x greater than or equal to 140. And now divide, and let's see what we get. 140 divided by 750. Looks like my adult tickets have to be greater than or equal to 18.6 repeating. I can't really sell 0.6 of a ticket, so I'd have to go up. So I'd have to sell at least 19 tickets. And that would put me over the 240. So the graph kind of said somewhere around 20, but it wasn't perfect. But when you do the algebra, it'll actually break it right down to where you need to be. So that's kind of the power of doing the algebra. All right, last one. I'll kind of blow this back up a little bit. So I threw one in here with a fraction just so that we could kind of have to deal with it. And here's how I would probably do it. You could, right now, multiply by 3. And remember, since it's outside parentheses, you just multiply the fraction by 3. But maybe you say, well, I want to distribute. Let's just see what shakes out there. So you'd have 2/3 times 2x minus 2/3 times y is greater than 2. Well, 2/3 times 2x, that's 4/3 x minus 2/3 y greater than 2. Now I can clear it out by multiplying everybody by 3 if I wanted to. So now I just multiply everybody by 3. This looks a little nicer because you'll have 4x minus 2y. I don't know why I put 4y there. Is less than 6. Now I could use intercepts, but 4 doesn't go into 6, so I'm going to go ahead and just keep going. So I'm going to have negative 2y less than, let's move the 4x over here. And let's divide everybody by negative 2. Since I divided by a negative, be careful, I have to flip the sign. And now we can graph that. So I need to start my intercept at -3. My slope is 2, up 2 over 1, 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 2 over 1. Boom, boom, boom. Because this is just greater than, it's going to be a dotted line. Boom. Good to go. And then last thing I need to do is I need to shade. And since it is greater than, I need to shade above the line. And above is going to go up this way. And if you don't really like the shading above or below thing, choose a test point. Put 0, 0 in. See what shakes out. Is 0 greater than 2 times 0 minus 3? Well, yeah, 0 is greater than -3. That's true. So you would shade the 0, 0 side. Now, we've been lucky. We've always been able to test 0, 0. Sometimes 0, 0 is on the line. So you got to pick like 1, 1 or 2, 2 or some other easy point to plug in. All right, hopefully this helped get you ready for the practice. If you have any questions, ask me in class. See you.